So for 17b, they're asking us to express the velocity of the airplane relative to the air and the velocity w of the wind in component form. So let's think about the airplane first. So if we look back at part A, okay, we know that this is the vector represented by the airplane. Its magnitude is 500 because it's traveling 500 miles an hour. And we also know that this angle is 30 degrees. So that means that this triangle right here, this blue right triangle, has an x component in this direction and a y component in that direction. And we know that this angle has to be 60 degrees since this one was 30. So we can represent this as 500. Sorry, my pen is dying here. We can represent that as 500 times the cosine of 60 degrees. That represents this distance here. Likewise, we can do that here, and that would be 500 times the sine of 60 degrees. So I'm gonna go ahead and write those over here on the other side, okay? So V is gonna be represented by, I'm gonna say 500 cosine 60 degrees, and then that's the I component, and then 500 times the sine of 60 degrees, that's the J component. Now we know what this is and we know what this is. So cosine 60 is a half. So I have 500 times a half in the I component, and then 500 times rad 3 over 2 J in the J component. Now this, of course, is 250I, and then this is going to be 250 rad 3 J. So in component form, let's just call that 250 comma 250 rad 3. There's a 0 there, okay? So that's the one that you do for part B for the airplane. Let's take a look at the wind now. We can do the same thing, right? If this is 50, that means the leftover part right over here has to be 40 because it adds up to 90. So there is a component here that is going to be 70 times the cosine of 40 degrees. That's that component. And then this component is going to be 70 times the sine of 40 degrees, but that's going to be negative because this component is going down. So again, this is the x direction and this is the y direction. So this is going to be 70, which is the magnitude of our vector v for the wind. So 70 cosine 40 and then negative 70 sine 40. So let me go ahead and write that down over here. So W was going to be 70 cosine 40, and that's in the I direction, and then plus, actually I'm going to say minus because we know it's negative, 70 sine 40 J in the J direction. So when you plug this into your calculator, you should end up with 53.62, and then when you plug this in the calculator, you should have negative 45, rounded, so 0.00. So now we have vector V, which is the airplane relative to the air, and then vector W. So in this component form, so this is vector W, this is vector V. These are the component forms. We're going to use those in the next part.